All right. Hi, everybody. I think we're going to start. People are still walking in, but we're past the hour. So welcome. Thanks for joining this session. My name is Vincent Hardy. I work at Adobe Systems, and I'm here to talk to you about CSS Shaders, which is, I think, a very exciting new feature we're working on for CSS. So cascading style sheet brings I think a wealth of new feature to what you can do in terms of rendering and animations on the web. So before I get started, if you're connected and you want to follow along, there is the presentation is online. That's the URL. So it's a bit.ly URL KMOGM5. So I'll give you a second to write this down if you want to go there. The catch is, the first slide will tell you need a special build of Chromium to view it, because I'm using some leading edge features, but there's a pointer to the binaries you can download, and then it should be a few minutes, and then once you have the download nailed, you can do the presentation and see the same thing I'm showing. One catch, if you look at the navigation, this presentation, by the way, is all written in HTML5. I'm trying to use the things that I talk about, and it's also an HTML5 conference, so it was appropriate to use HTML5 slides. The catch with this is that in the lower right corner there are arrows, and the presentation is made of sections, and sometimes the sections go down, so you have to use your arrow downs to see it. And the reason I'm saying it is, in the past, some people have sent me feedback saying, well, your presentation only had 4 slides. I'm like, well, it actually had 4 sections, and they were about 30 slides. So be aware of that if you start. So hi, a little bit about myself. So I've been at Adobe for a year, but I'm a web head and a graphics head. I've worked on scalable vector graphics since '99 in the Devil's Receipt, been involved in open source projects like Boutique at Apache. Working on the Devil's Receipt specifications, the scalable vector graphics specification, the compound document format specification, which preceded HTML5, and trying to combine a bunch of technologies on the web. At Adobe, I work on a group called the Web Platform, and the group I'm part of works on standards and innovations. That means that we're trying to we participate to web standards, meaning we go and edit specifications like the one I'll talk about today. We contribute to test suites, everything we can to help move things forward. And we'll also try to bring new features to the standards. So we're trying to think about new things that are missing or we think would help, and we try to make proposals and implementations and bring that to the standards. So that's what I do, and I'll share some of the work we're doing there. So CSS Shaders. So what is this? So this originally is a spec. It's a draft. It's a document. It's about 30, 40 pages long, and it explains how to use hardware accelerated filter effects that have been traditionally used in gaming or OpenGL to the web. And I'll show you how this can be useful. It can be very much in your face, like animated GIFs, or it can be used for subtle effects. So for example, here you can see that this image is slightly distorted to give it a more natural look, and this simple effect is done with a simple shader. And nothing much about it, but it enhances the user experience. So this is something we brought to the Devil's Receipt back in October, and the groups talked about it and decided this was something they wanted to have in the standard. And the resolution was to add it to the filter effects spec, which is a more generic specification about how to do filters in CSS. And filters in general are exciting. Shaders are super exciting, of course, but I wanted to talk a little bit about shaders, because you might be wondering, what are filters in general? So, to relieve anxiety about this, it's actually quite simple. So if you want to apply a filter to an element in CSS, the only thing you have to do is attach a filter property on the selector, so to set it on the element, and then you specify the filter function or you reference the filter you want to apply to the element. And there are 3 ways of defining filters, and I'll describe those 3 ways shortly, and the presentation will then focus on I was saying there are three ways of defining filter effects values: shorthand, SVG filters, or CSS shaders. So I'll focus later on CSS shaders, but I wanted to show you and give you a feel for filters in general. And I'll take a 1 minute break to set up the clicker that will make the presentation and go more smoothly. Okay, so the first way to specify filter effects in CSS is with shorthand filters. So shorthand filters basically are fairly simple. You specify the filter property and you give it a shorthand name. So imagine you have an image like this original here that you want to apply a filter to. You can attach a filter function grayscale with an amount of 1, means full-on grayscale, and this is what you'll get. You'll get a grayscale version of the rendering. So what happens is, as all filters do, what they do is they take the rendered content and then make it go through the filter, and the filter modifies the pixel values or the geometry of the thing you're rendering. So that's the first example, and it's a fairly simple one. You've got other effects like sepia, which does sepia toning on the image, saturation, which will make your image more or less saturated. Hue rotate, which will change the color on the color wheel. The opacity, which is fairly straightforward, but can be useful combined with other filters. Invert will just invert each of the color components. The brightness will adjust the brightness of the image, and I have a slight problem here. So, all right, so that one. Saturation, blur, and drop shadows are the other ones. You can't see the title, sorry, this is cut out. So those are very simple effects, and the nice thing is they're extremely easy to use. Just set the filter value and the property and the shorthand filter name, sometimes as a parameter. They're limited though. I mean, they're very useful. They're meant to address very common needs in filtering, but they're limited. So the next two solutions we have for filtering are a little more sophisticated. So the first one is SVG Filters. So they're called SVG Filters because historically SVG had filter effects since the beginning. And now they can be applied not only to SVG content, but to general CSS content. That's an example. So here we have a piece of text, and I'll prove this is text by selecting it. So I can do text selection. And if I toggle the filter here, I apply a fairly sophisticated filter effect. So the filter effects is made, if you're familiar with a tool like Photoshop or GIMP, this takes the original rendering, does all kinds of blur, masking, 3D lighting, and combining the things together to give this kind of golden chisel look to it. So that's a fairly complex filter. Something you would do typically in an authoring tool, but now you can specify this with markup. You could control the different attributes and properties of the filter, and you can attach it to any element. So right now, this works. It's really easy to use as well. It's declarative, as I was saying, and it has some limitations in that there is no way currently to specify parameters like you do for shorthand filters through CSS. So for example, you remember in the CSS grayscale filter, for example, you can say, you want a grayscale from 0 to 1. That's very easy to specify in CSS. If you use SVG filters, currently there is no way to pass parameters to the filter. And currently, it's only implemented in SVG content in most implementations, so you can only apply the SVG filters on SVG content. This is going to change because the specification says those filters must be applicable to any type of content, but that's not what implementations do yet. Now, this is an example of a CSS shader. So that's a third type of filter effect, the one we proposed last year. And this is an example of rendering, of HTML rendering, where you can, this is still HTML, I can select the text, etc. But when I hover on this, the shader gets applied and it distorts the geometry of the rendering and also applies shading. I don't know if you can tell, but there's a little bit of shading in the curves to make it for a more pleasant visual experience. So that's what I'll talk about today. And the way you use custom filters, CSS Shaders is the same way. It's very simple. It's a custom function with some parameters. It's very flexible in terms of what you can do. It's an imperative programming model, as opposed to SVG filters, which are declarative. So SVG lets you define a graph of nodes through markup. Shaders, by contrast, let you specify little programs that will explain what the shaders do. And in addition to what CSS filter shorthands and SVG filters do, they all do pixel manipulation. CSS shaders add one thing, which is 3D distortion of the rendered content. So you can imagine you have a surface. One of the things CSS shaders can do is distort that surface into a 3D space before it actually applies pixel manipulation to the content. And the last thing is that they're very easy to parameterize, and we'll talk about how important that is later. So finally, you should know this is leading edge. I mean, as I said, you have to use custom prototype build of Chromium to view the slides or to view CSS Shaders example, but it's coming. We're currently busy actually contributing this to the main track of WebKit, so it's going to come very soon in browsers. Now, how do you use CSS Shaders? So that's the model I was just describing. So on the far hand side, and I apologize if that's too small from the back of the room, but the tiny thing you see on the left-hand side is the rendering, the HTML element you want to render. So imagine this gets rendered into an off-screen buffer. And the first thing the shader will do is that it will use this on a mesh of coordinates. And in step 2, the vertex shader, the so-called vertex shader's job is to actually manipulate those vertices. So you can distort them into a 3D space and create the kind of warping and curving effects I've shown you before. In the third step, the fragment shader, or pixel shader, will do what you would expect a filter. It will actually take input pixel values, manipulate that value, and then change it and output a different color. So that's how you would do something like sepia toning on the right-hand side. So I'm first going to talk about how you use shaders in practice, because that's the most common use we expect of it. And then in the second part, I'll talk about how you can actually write shaders, which is a little more advanced. So let's see how you use shaders. So first off, as I was saying earlier, the only thing you have to do is you specify the filter property and the custom function, and then pass a number of parameters. So the parameters you have in a shader are, first off, you can specify the vertex shader. That's the one that distorts the geometry, again, for page curling or any type of effects you may want to do. Optionally, you can specify a fragment shader, which is the one that will do pixel manipulation and change the color values, basically, on the rendered content. Then you can specify the vertex mesh. So if you remember the little drawing I had on the rendered content, we applied a mesh that you can distort. Well, by default, there's actually only 4 corners to this mesh, and it's fairly coarse. But if you need a smoother distortion on your content, you can specify how many dots you want in your mesh, basically, and that's what the shader mesh does. The second thing the shader mesh allows you to do is you can decide if the little tiles you're going to define on your content are attached or detached, and I'll show examples of that later. And then finally, and this is very powerful, you can specify parameters. So as you write a shader, you actually have control over parameters that they take, like the amount of the effect you want to apply, etc. And you can specify them through CSS, and I'll show examples of that later, which makes them work really well with CSS animations and transitions. So let's start with the vertex shader only. So as I said, you specify the custom function, and you point to the vertex shader. And here the 2-2 parameter just means we're talking about a 2x2 vertex mesh. So this is the HTML element we want to shade. So here, realize this actually has an image element and a P element inside a div, and we're applying the shader to the div. And this is what this particular shader does. It applies a fold, meaning that it just plays with the y coordinate on the mesh. And you can see that the mesh is 2 by 2, meaning that there is So there is a mesh point here, one one in the middle here, one in the center, one here, one here, one here, and one here. And what the program does, the little vertex shader program does, that it actually moves those mesh points to create this folding effect. All right. So now if we add a vertex shader, so why would we add a vertex shader? So for example, when you do folds, it's kind of nice to have a little shading in the fold to emphasize that this is where the seam is, for example. So what we need to add compared to what we had before is just a reference to this fragment shader that will do the shading. So again, if I apply it to my content, you can see now that in the fold, in the center, I'm able to actually apply kind of a nice gradient that emphasizes the place where the fold happens. So it's a fairly subtle effect, but it's pretty powerful, and it would be extremely hard to do otherwise. So now, as I was saying earlier, there is this really great feature that you can specify parameters. So imagine here, and I'll show the code later, that the fragment shader and the vertex shader expect a parameter called amount that will tell them how much of the effect they should apply. And I've done that here on this shader, and the little slider here is set at 0.5, means that the effect is kind of midway. And if I move the slider, I can change what this parameter is like. So if I put it fully on, this is the maximum of the effect applied. And if I put it at 0, like no effect applied. And you see that both shaders use the parameter because no folding applies and no shading in the center applies either. That's pretty powerful, and I'll show later that this can also be used through CSS animations and transitions. All right, so now the part which is a little more rocket science, but not that much, I promise. This is about shader code. So how do you actually write a shader? So first, the vertex shader. This is kind of the boilerplate. You have to, we're using GLSL, which is the OpenGL shading language specification. That's the one that we recommend be implemented by CSS shader implementations. So we're just adopting that language, and it's a C-like syntax. So if you've done C, it's not too hard to follow. And the 15 lines of code here make up the last shader I showed. So first off, there are attributes. So attributes in shaders are properties of each of the vertices that get passed to the vertex shader. So remember, like I have this mesh of points that I get fed into the vertex shader. Each of them can have attributes. So here, remember the one A position, which gives you the coordinates of each of the shader points. Then we have some max amount parameter, which we use in the shader code. The uniform. So uniform is the binding you have really between the CSS shader code, where you pass a parameter to the shader, and the shaders themselves. So if you in the previous code I showed you there was an amount parameter passed into the custom function. That amount parameter is found as a uniform in the code for the vertex shader and the fragment shader, and they can use it to tone down the effect. It's not limited to an amount parameter. Here we're using a float, but it could be a transform, it could be a texture, it could be a vector. It can be all types of parameters. Here I'm using the simple form of that. Then I have another uniform, and this uniform is passed by default. So I'm not going to talk too much about it, but this projection matrix, basically think of it as anything that needs to be applied in terms of coordinate system between your elements coordinate system and the viewport coordinate system, meaning the page you're rendering into. And then it will take care of any transforms that are applied on the parents or any kind of layout you have on the page. So it's just something that you need to multiply with at the end of your vertex shader code. Then the varying parameter. This is another type of parameter. It's a parameter that a vertex shader and a fragment shader can pass to each other, and we'll see how that's useful. So you have a main function. This is what the implementation will look for when it tries to apply a vertex shader. The main function will be called once for every vertex in the vertex shader in the vertex mesh. So here we're copying the position because we cannot modify the egg position directly, so we copy it into a variable. We compute an amount based on the amount parameter that gets fed to us. We clamp it to the 0-1 range, and then we multiply it by the maximum amount we want to allow in the shader. Then we derive an amount that will be used in our computation, and this amount t here that we compute here is used to modify the position, the y position of the vertex. So that's the one that creates the shift down in the center of the fold here. And we also assign that value to the shadow varying. And the shadow varying, remember, is a parameter that gets passed to the fragment shader later on. And then finally, what we do, as you do in all vertex shaders in OpenGL, is we compute the GL position, which is a new position for the vertex. So we compute the position that the vertex will really have after transformations for the vertex shader. So the thing to remember here are that the vertices have attributes. So each vertex in the vertex mesh has attributes, and the most important one is the position. There's a number of other attributes that can be useful in other situations, more complicated situations, but the most important one is a position. The shaders receive parameters uniforms by the implementation, like the projection matrix. So this there's a set of useful default parameters that you need to know about, like the size of the texture you're manipulating, etc. And there is a set of author-defined parameters, like amount, that get passed to the shader as well. So two types of uniforms, some passed by the browser and some passed by the user and the author of the shaders. And then finally, the shaders can pass parameters to each other, like with varyings. And we'll see now how this is actually used in the fragment shader. This one is actually remarkably simple. It's only 6 lines of code. We declare the varying that we're expecting from the vertex shader. So here we're saying we're expecting this shadow varying. We're getting the amount as well. That's a uniform that gets passed to both the vertex shader and the fragment shader. And we use this to compute the amount of shadow that we're going to apply to the content. So as you see here, the amount we're going to apply is, using the shadow varying we had, we multiply this by the amount, and by default, we just apply a small amount, meaning it's, the color is going to be full on white basically, and it will get darker if the shadow parameter goes up to 1 or higher. Now you'll notice that this is computing something called the CSS blend color. And this is not traditional GLSL. In GLSL, you compute something else. You might be wondering why that is. So, if you're a GLSL, an OpenGL developer, that's probably the face you're making because you're wondering, where's my GL frag color? This is what I've computed all my life in fragment shaders. What's up with that? And how come I have no texture access? And the reason for this is that we've run into a bunch of security issues with CSS shaders. And I wanted to talk a little bit about this. There's been blogs written about the problem, and we've actually worked for about 6 months on how to best resolve that problem. So what are the threats we're really dealing with CSS shaders? So the first one is Shaders are programs, and they basically manipulate rendered content, and that means they get access to the pixel values of whatever you're drawing, if we didn't do anything else. So if you give shaders access to rendered content, they get access to sensible information like third-party content. If you're, I could create an iframe, put, mybank.com content in there, and then the shaders will get access to it. Or I can get access to user agent data like the visited links or the dictionary content. So how is that actually working? So the way it works is the shaders can do something that's called a timing attack. So the timing attack is the shaders look at the pixel value they get, and depending on the color, they will take a smaller amount of time or a longer amount of time to execute. So for example, if I'm trying to make the distinction between red and green, I'll run my shaders such that if it's red, I'll execute really quickly, I'll return very quickly, and if it's green, I'll take a long time to compute. And someone who's observing the behavior of the shader and the time it takes between rendering can infer from the time it actually took to process a pixel value if that pixel value was green or if it was red. And that's really bad news if they're rendering your bank account or if they're trying to figure out if you visited a website. So that's what they do. And it actually sounds crazy. Frankly, we didn't think about that attack originally with CSS Shaders when we made the proposal, but it actually does happen. And it's been shown on WebGL. So since we were using the same shaders, there's been an attack demonstrated on WebGL that was very effective at reconstructing images, whole images. And internally, we've been able to reproduce this for access to visited links. So we could write a shader that had access to rendered content and know very quickly if the person had visited any website, basically. So clearly, that's not a good thing. So the way we're proposing to remedy, to fix this issue currently after a lot of discussions is to just simply cut out access to the rendered content. Meaning that the shaders don't ever see the pixel values in the process. So if they don't get access to the pixel values, they don't have access to sensitive data, neither third-party content or user agent data like visited links, and the problem those specific threats go away. It still preserves a lot of the functionality. All the demos I've shown so far are with shaders that don't have access to the rendered texture, the rendered content, and there's still a really useful functionality there. So that's what we're working on. So we're working on this shader rewriting that's needed for the fragment shader, the part that computes the CSS blend color I showed earlier. This is an intermediate shader. The technology we're working on rewrites this shader to be a normal shader that will generate a GL5 color. There's a little bit of magic happening there, but it's safe magic, and it prevents the shaders from ever having access to sensitive data. And we're also trying to analyze the GPU execution patterns. There was another option to address the CSS security concerns, the shader security concern, and that solution was to detect if the shader was doing anything based on the pixel value it read. So, for example, if we were able to detect that the shader is actually reading a pixel value and then branching off, depending on the pixel value, we could determine that this is actually a security breach and make that shader invalid. But if the shader was not doing any kind of color-dependent decisions in its processing, then we could say, well, that's a safe shader. It's not trying to do anything evil, and allow it. So we worked on that. We actually had a successful implementation of that option. But then the issue that came up was that arithmetic operations, just plain multiplies and divides, may depend on the input parameters. So for example, in some architectures, if you divide by none or by not a number, or if you use infinity, the scale of time you're on varies, one or two folds. So we're still trying to investigate if that's the case on GPUs and if there's any way to work around that problem. But in the meanwhile, we're sticking to no rendered content access, and we're hoping that we'll be able to lift some of the restrictions we're now recommending. Okay, so now let me go back to CSS Shaders and CSS, the graphical stuff, and I'll show a few more demos. So the parameters I showed earlier, remember the slide where there was a slider and that was letting me control the amount of shading I was applying? Well, those parameters can equally well be applied with CSS animations and transitions. And all I need to do is to say that in the case of transitions, for example, I can just say that I want the filter property to be transition, and I do that like I would for the width property or any other CSS property. So I say here, transition the filter property in a linear interpolation way over a period of 0.5 seconds. And then if I have an element here, I can say, my regular element has a grayscale filter applied to it, it's full on. And this other element has a shader applied, it's called a wobble filter, and you'll see why shortly. And it's not wobbling at all by default. And when I hover on the element, what I want to happen is I want the grayscale to go away, so I'll put an amount of 0 for the grayscale, and I want it to wobble completely. So what should happen here is that if I apply this to my element, here the structure of this is that the external element, my other element, is actually the parent of the HTML5 logo. So this is the one that has the grayscale filter applied to it. And the HTML5 logo itself has the wobble filter applied. And now if I go on top of it, all right. That wobbled. All right. So that's kind of stuff you can do. It's extremely useful to have this on your webpage, of course. But you get the idea. It plugs really well into the CSS animations and transitions, and it's extremely easy to use. So I think the thing to take away from that example is that while writing shaders may take a little bit of effort, and I expect that there's a lot of people who have a lot of talent in writing shaders. I expect a lot more people to use shaders that have been defined with a nice set of simple parameters to tweak them, and then plug that into web pages and animate your CSS animations, transitions, or just scripting. All right, so even then, that can be a little overwhelming. So we've been working on a tool. It's called the CSS Shader Studio. That will help developers. This is not public yet. Everything I've shown you so far is public. The CSS Shader Studio is not public yet. We're working on it. It will, I hope, soon. And this tool lets you play with filters and do really fun stuff. So let me show you an example.
Is it free?
Yeah, this will be free, yes. So this is an example of more sophisticated filters. I can move things into a 3D space so that you can get a better sense of what's happening. And here, this is a good demo to understand how the mesh works. So here, I actually have a little UI that shows me what the vertex mesh is. And when I select a point, you can see I can move it around. And I can actually move it in the 3D space, so I can click here. And I can do my kind of curl, the curl I want here. All right.
When do you guys plan to release it?
Okay, the question is, when do we plan to release it? I hope pretty soon, so in the next couple of months, I hope so.
But then the browser is not to support like the
That's right. So the browser, there is a prototype build that's actually able to render this today, and this one is public already. We're working on making the code that we have in the prototype build be part of the main trunk. And then once that happens, we want to make the CSS Shader Studio available. All right, so this little tool will let you do things kind of visually and graphically, and we'll show you what the result of the resulting animation is. So, will be helpful. Here you have, again, this is a little bit of a crazy filter because there's lots of parameters, but it shows that it's possible, and it will also help you with the animation code that you would put into your page. So that's one example. Another example is the fold. So you can do, we can fold this thing. You can, rotate it on the different axes. So we can do, really fun stuff, and I think this can be useful. So of course this is, a little bit in your face. As I said, it's like the animated GIFs. That's why I started with less, conspicuous examples. But our expectation is people will use shaders in a very subtle way to enhance the user experience. Yeah.
Is it possible to keyframe these animations? So if you have it where it's set up where it's folded like that, and then the person clicks on it and then it unfolds.
Yes.
And it becomes more clear.
So the question is it possible to keyframe those animations? And the answer is yes. You have the same tools you have with CSS animations in general. And our little studio tool here actually lets you add keyframes. So again, let me do it on a different different effect here. We'll start with a little bit of scroll. Then if I move to the center, we'll say we want full scroll. Thank you. And at the end, we'll just come back here, for example. So if I come back and play this, that was a little fast, but all right. That's pretty cool, huh? All right. Thank you.
Do you know when
Thanks.
it may get adopted in the iCloud?
So that I don't know. I mean, I wish I knew Apple's product plans, but I don't. But we're co-editing the specification with Apple. So so Dean Jackson at Apple is actually working on the specification with us. So I think that shows they have interest. And they've been very active with filter effects. I mean, filter effects in general are starting to make their way to Chromium, and they're starting to land into the important builds at Apple. So my hope is that we'll see that on the iPad one in the not too distant future. But I can't speak about their product plans, of course. So we'll get to that. So the question was about the L3C process approval, and I will talk about this later. So all right. So that was the CSS Shader Studio. The status to your question. We're working on a security update. So we published a draft. There was an agreement back in October to integrate this into the CSS filter effects spec. And it was really well received by the group. The holdup has been on the security issues. It's very important that the L3C, and rightfully so, takes all the security issues very seriously. And we didn't want to publish a first public working draft that was, a spec where we knew there was security issues. So now that we have a solution, I was actually in a working group meeting 2 weeks ago, and we presented the proposed solution for addressing the security concern, and the group agreed to put that into the spec and publish a first working draft. So that should happen, I hope, in the next 2 months. We'll do our bit, and we'll work with others to get the spec published. We're working on Ygl. So Ygl is maybe a little bit of an obscure thing, but it's an open source project that's used by different browsers to deal with shaders. And Ygl has a lot of things that it helps with for the WebGL implementation. And this is where we're adding all the shader analysis code and magic we're doing to do the shader writing that's needed to make the shaders safe. And we're contributing the code I showed you to the main trunk of WebKit. So this is happening. And this is part of what we're trying to do in our group. So we're trying to, leading the web to its full potential is a Dell3C tagline. It's, I think Tim Berners-Lee said that one day. And in our group, we're trying to bring every stone to the bidding, bring the web to its full graphical potential with things like CSS Shaders. And this is pretty exciting. There are other things in the presentation. I don't know if you noticed, but there was one diagram where I was using compositing, which is a very simple way to blend what you're drawing with the surface on which you're drawing. So if you're familiar with authoring tools, you can have multiply, or you can have screening, or you can have hue or saturation type of blend modes. So we're also working on a separate spec called CSS blending and compositing. Compositing and blending, actually, and we're also working on the implementation in WebKit and in Firefox, in that case. In general, we're very interested in helping test the web forward, help move the web forward. There's actually an event in San Francisco in a couple of weeks. If you're interested in web standards, and I assume so because you're all here, and if you want to help test and debug browsers and have better interoperability, please check out Test the Web Forward. It's in I think June 16 and 17. I think. Sorry, I shouldn't have the date in my mind, but it's a Friday, Saturday, and the event will present how to write tests for Dell3C test suites that all the browsers use. And the second day will be about hacking and writing tests for a number of specifications. Then I wanted to show you last thing. So there were questions about what is available. So what I'm showing you here is running off my local host because of network access, but this is actually publicly available. So it's a page that explains all the features of CSS Shaders. It has code samples you can go look and study and learn from. Some of them are fun. For example, like this one. And this is all available online. So if you check it out, you go to html.adobe.com, and from there you'll have links to the build you need to run this, and the links to the page I'm showing you right now, if you want to see more examples. All right. And if we have time for a fraffle, does anybody know what a fraffle is? No? All right. I didn't know until Friday. I was trying to figure out how we... so is anybody interested in having a copy of CS6 Web Premium? Yeah, a few. All right. Okay. So I have 2 copies. And the raffle is a phone raffle. And I'll get there. Okay, so it's... Give me 1 second because I actually need to connect to this. But so I'll explain how this works. So I'll use this little application that will get random numbers, and I'll ask everybody to stand up initially, and when the first number comes up, if that's the number your own cell number ends with, then you stay up. If it doesn't, then you sit down. And I trust all of you. Then if there are multiple people, which I assume will be the case here, we will go for the second number, and then we'll see if there are more people standing up. And we'll do that until there's a winner. Okay. Okay. So first, everybody stand up, please. Okay. Well, anybody who wants to try to win. Okay. Okay. So the first number is. It's a 3. I'll have to be able to give you a call, by the way. Okay. There are a few people with a 3. All right. Second number is a 1. Anybody with phone number 1? So 1 person here. Anybody else? Can you raise your hand? There's the lady here. Anybody else with 13? 2 people. Perfect. I have 2 copies, so you get that. Perfect. All right, so please come and see me just at the end. I'll take your email address and we'll send you the copy. So before you go, again, I want to thank you for joining. The slides are online, you can check them out. I can be contacted here. All the information about Twitter, etc. is available. And if you want to learn more about what we're doing around HTML at Adobe, you can check this address, which has lots of tutorials. Thank you very much.
Let's see.